today for you. My name is Azarakhsh, yeah, because I have a very long name. Everybody calls me Azar. I'm totally fine with this name. I was born in Iran. That is my picture there. You see it with the sun in my face. That is Iran. And in 2009, I immigrated to the Netherlands because in Iran, I met my husband and I have a Dutch husband. And then we decided to live here in the Netherlands. And then I have my master degree in remote sensing in the Geomatics group of Faculty of Engineering in University of Tehran. And I have finished my PhD here in Geographical Information System of the Spin Lab in Vrije University in Amsterdam. I started to work in 2010 by GeoDelta. Actually I worked more on the quality control and the quality control of geospatial data, aerial photography, bundle adjustment, quality control of the LiDAR data. Also working on some image matching techniques. After that, I worked in Geodan, Geo ICT company. So this picture is also there when we were in the working on the dashboard and actually touch table at that time, I would say. And there I worked in the research and development department. So from the beginning in 2011, I worked on the 3D GIS. And what the role of the 3D GIS in urban planning and environmental analysis is, that focus on the built environment. And then I have also, meanwhile, I was also doing my PhD by Spin Lab in Vrije University, Amsterdam. And there I was a researcher there. And also I did the teaching, the different, actually more focus on remote sensing, but also like big data analysis and infrastructure and supervision of students in different fields of GIS I did. And at this moment, I also work by GeoNovum. We are working on a Dutch noise model team. It is called EM and we want to see how we can make it conform, inspire in that to be also conform in Europe. So that was more an introduction of me. Today I have 4 goals I've defined for the presentation of today. I really hope that after this session, the participants, they are just enthusiastic about the capabilities of different sensing technology for the analysis and design of the built environment. And I hope that the participants, they have an overview of what geospatial technology mean for the research innovation, what are the capabilities in real projects, and that they see the potential of sensing technology discourse, how it can contribute to the MSc Geomatics. And then of course, at the end, I hope that the participants are convinced about my skills and expertise as a researcher and a lecturer in the GIS technology team. So to be able to reach these goals, I have defined some contents of the lecture for today. So first we'll have an more overview on the different sensing technologies. We will see I show some examples of the capabilities of GIS and sensing technology, geospatial information in real projects, in research innovation. And then we will have some discussion about the integration of data and what are the considerations about it. And after that, I will cover some talks about the contribution of sensing technology in the MSc Geomatics curriculum. And at the end, I talk some about my potential contribution in the research and education of the GIS technology team. So I start with the sensing technology overview. So actually, geospatial data, they can be acquired from different sensing platforms. We have the popular ones are satellite imagery, aerial photos, street images, street view images actually. We have data from terrestrial laser scanning, airborne laser scanning, and the real-time sensor data from many different devices today. So actually, GIS provides more like a platform for managing this data from the acquisition to storage, data analysis, serving and visualizing the data. After that, beyond that, actually, we will also have advanced technologies like machine learning, computational geometry, and simulation models. And this helps for the extraction of information from the raw data, and after that, knowledge. We can use it for pattern analysis, for future predictions, and also for scenario analysis in the built environment. So in the following slides, I will present some of the examples of the data that are captured from these different sensing platforms. I start with remote sensing. Actually, remote sensing concerns about the acquisition and analysis of information about an area by measuring its reflected and emitted radiation at a distance. So what do I mean by that? For instance, here, take a look in the case of a passive sensor. Here, the radiation source is the sun. And here, when the radiation reaches an object, different interactions between the radiation and object surface occurs. And this depends on the wavelength of the radiation and also on the physical properties of the object. So like when the radiation just comes to the object, part of the radiation is absorbed, part of it is emitted, partly is reflected. And we have, of course, also the interaction of the atmosphere with the radiation. So here, the multispectral sensors, what they do is that they record these reflectance in different wavelengths. And here we can, for each wavelength, we can see how much radiation is reflected to the sensor. And actually based on that, we can see and estimate the physical property of the object and understand the land cover content of an area that we are sensing. Here's an example of actually classifying, and here's Sentinel-2 image. Here we have used different bands of it. So in the left image is a raw image, but this is only RGB. But for the classification, we use the different bands of this Sentinel-2, and then you can use different type of classification algorithms here, like some machine learning algorithms like neural network, support vector machine, and maximum likelihood. So you can use this algorithm to classify your image. And this data is, of course, very, if you can do this in a large area, you can use it for many different applications. You can use it for land cover monitoring, change detection, and many, many more applications. But next to the spectral information, we can also use the remotely sensed data for capturing the height data. Here's an example of a stereophotogrammetry. So the idea is that by stereophotogrammetry, we can estimate the 3D coordinate of points on an object by measuring the object point in 2 or more overlapping images that are taken from different positions. And here the output, we see it in the right image, is a 3D point cloud, and it is directly, has RGB color, has texture. And this 3D point cloud, it can be used for later on for 3D reconstructions of city or objects. And beside the aerial photos, the other source of information here, we have also street view images. So these are more obtained from cars that they drive through the cities and urban areas. They take panoramic photos, and actually a very popular supplier of that is Google. This data is used a lot for navigation, but we can also use it to extract other type of information. Here I have 2 examples of it. For instance, here again with the technique of the overlapping photos, you can generate 3D point clouds, which has already colored from these panoramic images. You can also use another study, for instance, that they have used it to classify the functionality of a building. It's an apartment, is it an office? So they have used the street view images, and they use convolutional neural networks to classify these images. Now we come to the popular, my popular data set, which is airborne laser scanning data. Actually, this for this laser scanner, it can be mounted on an airplane or a helicopter. So you can, or a drone, you can, the main component of the system is actually the laser scanner. the GPS and INS, and a timer which is there. So the idea, the basic of the technique is that the laser scanner, they send a laser pulse and get it back, and the timer accurately measures this distance. Yeah, and we know the velocity of laser pulse, so we can know what's the distance from the airplane to the point. And this in combination with the GPS and INS, with this we can just get both horizontal and vertical coordinates, X, Y, Z of all the scanned points. And this data set, we can use it for a lot of purposes like rooftop detections, 3D, actually reconstruction of the city. And we have in the Netherlands, this data is an open data. We have it for nationwide, AHN2 and AHN3, and now it's AHN4 also being captured. So this has a lot of capacity in the Netherlands because it's open data. And we can also have the laser scanner, the same principle, but on the ground. So here, we have two types of system we can have with this: terrestrial laser scanning and mobile laser scanning. Actually, terrestrial laser scanning, it's mounted on a static tripod, and it can just send the scans and get it back in all directions, also upward. And with the mobile laser scanner, actually the scanner, the system is mounted on a moving car. So these two techniques are popular land surveying methods. They accurately measure the 3D point cloud. Like the Airborne, the result is the same 3D point cloud, but in the case of terrestrial and mobile laser scanner, we have much more dense data and much higher accuracy. But of course, the analysis of it is also becomes more difficult because it's also more prone to unwanted objects when we want to do a modeling. Here I present two examples of it. For instance, this is data from a mobile laser scanner. This has been used in a study for detecting the detection of the traffic lights, traffic signs, and poles. This can be used for different type of analysis in urban environment. And here is a result from the terrestrial laser scanning. You can have the data, very dense data on the structure of the tree. You can use it for forestry studies very efficiently. You can measure the geometrical properties of a tree. So this has a lot of application in forestry. And last type of sensor that I wanted to talk about is the geospatial information can also be acquired from different type of real-time sensor data. So we have it from different devices, and it's coming more and more and more from GPS data, from weather stations, from traffic, from everything we can these days have the data and real time. And here we have the concept of actually Internet of Things, where this data, they communicate with each other, they talk to each other. And here, actually, crucial part of this data is location, because this data is about location and space. So location is a very important part. And from this type of data, we can do different type of analysis. We can extract different type of information. Here I show part of my own work, which I use the LSTM or short-term memory neural networks for the pattern analysis and for predictions, for weather station data, for traffic flow. So that was the overview on the sensing technology. So you see that there are really lots of possibilities that we can use with geospatial data. Of course, we also should consider the different parts of it, how this data should be integrated with each other, volume of data, and that's why having a proper spatial data infrastructure, that is very important. So now, actually, I would like to show some possibility. I mean, some of this application of this geospatial information in my work, in my own work, especially for the answering of different research questions. So I start with the first one. Actually, here I used geospatial information to analyze and understand the local impact of tree volume on the urban heat island of Amsterdam, because because of the growth of urbanization, we have urban heat island in cities are really one of the biggest problem. So we should see that how we can mitigate it, and to understand it first, we should know which elements have impact and how then we can use these elements for the mitigation, and how urban configuration can help in mitigation of urban heat island. So here the focus was how much each extra tree volume, how it can contribute to the mitigation of urban heat island. Here I use this airborne laser data, airborne LiDAR data actually, and through this data, 3D building models and tree models were extracted. This detection of the tree models and parameters, it was done by Altera. And with these parameters, we could use the 3D model of the trees and calculate the volume. And beside that, I have also used the 3D city model to actually estimate the sky view factor by modeling the urban canyons. So you can see for each point how easy the heat can be released from a point. And these are the very local parameters. And we, of course, also took into account the urbanization degree. This is a more regional parameter. And there we could use it in our research question that how much tree volume and in how much distance it can help to the mitigation of urban heat islands. So here's another study which geospatial data was really the core of it. That was about analyzing the impact of spatial context on the heat consumption of individual households. So the idea behind that is that, space heating, especially in the colder climates, it considers, it is actually comprised, is a big share of the total energy consumption. So if we can reduce this energy, it can have a lot of positive impact on the reduction of the total energy. So actually there are four types of factors that influence the heat consumption in a house or in a building. One of them is the occupant's behavior, the efficiency of the energy system, the type of isolation, the architectural design of it, and the spatial context. So the first three ones are more individual choices. It's difficult to influence them through policy making or urban design. It's difficult to influence that. But the spatial context, this is more within the area of the urban planning, decision making. So if we can have an understanding on how this the relations are, this will help in making good policy about it. What I've done in this research, I applied different techniques for automated extraction of different urban 3D urban configuration parameters. Rooftops of the buildings, for instance, the shared walls and how much they have the heat transfer from different buildings, the building size, sky view factor, and different types of urban configuration. And I use it in my research process. And another example of my research with the geospatial data, it was integration of BIM model in a GIS environment. Actually, I focused on that was of 2013, 2014, those years was it. And it was about, how can a BIM in an automated way be placed in the right position and compatible with the 3D GIS data. So the idea behind this research is that the integration of detailed and semantically rich BIM into GIS, it provides a scope for understanding the mutual impact of a construction and its environment and during the whole life cycle of the construction. And this helps efficient analysis in a larger scale. So that was the idea behind it. And here we also used it in two case studies. What can this integration mean? One was for the view coverage analysis and the other for the shadow analysis. So by the view coverage analysis, I wanted to know from each window of the building how much content of how much green versus how much gray is. So how much we have building volume and how much we have tree volume. For the shadow analysis, I wanted to know for any time of the year how much of rooftop is covered by the shadow. Specifically, it is important for the to understand the possibilities for solar panel mounting. So with this integration, for this analysis, the information about the window and roof, they could just be extracted automatically from the BIM model. That was the reference, and this together with the 3D building and tree model, we could just do this analysis all automated and more efficient. So this can help different stakeholders like urban planners, for instance. This type of integration can help them in a more efficient analysis. Last part that I wanted to explain is about the development of a system that we had. It was an interactive 3D geodesign tool we have developed for the multidisciplinary wind turbine planning. This we did it together with the Department of Hydraulic Engineering in TU Delft. So the idea behind this is that, for the wind turbine projects, there are different stakeholders from different domains. We have citizens, we have technical stakeholders, decision makers. And there are always debates and challenges, and it does not go always very smooth. So the idea was that, maybe this decision making, if you have a good information system, this can help. So that's why we have developed a decision support system where the stakeholders from different domains and backgrounds, actually they can collaborate together for different type of scenario analysis. And the core part of the system was the integration of game engine, GIS, and simulation models. And this actually helped the seamless scenario analysis, scenario configuration, and real-time feedback on each scenario. So this helps actually the efficiency of the whole decision process. But the game engine helped in this way. It was for 3D rendering, enhanced visualization, but also the physics engine of game engine helps with the very optimized performance of like collision detection, for instance, line of sight analysis. How GIS can help is that, okay, you can do these nice things in game engine, but in a small scale. So GIS helps first by efficient bringing a serving of the geospatial data. So because there we have actually embedded web services and standard protocols. So so that this data they can be served there and they could be interoperable with each other. And beside that, the tiling techniques, it helped that you could just expand it for the whole Netherlands. So you could just navigate through the whole Netherlands and do any type of analysis there. So they were integrated. I mean, they have helped these both game engine and GIS to the simulation models, to the optimized performance of it. So that these advanced noise models or like wind models, energy yield models, they could just be performed in real time. I have here some examples. So here you have actually the whole system. You can have a different type of wind turbine from different supplier, and you have different characteristics of it, technical characteristics. You can use it, you can see it, but also it goes directly to the model. So if I have here a film, by adding a wind turbine to the scene, you can see how much actually noise each building receives. This one is about the geometrical spreading, so it's a function of distance only, this field. I think it should work like this. Yeah. So here you see that you can see in the charts how many buildings they have, how many decibels. So like the red ones are the highest decibel, above 55, and then you come to the lower decibels. And this you can see it in real time. And the fraction was actually the idea is that the higher buildings, I mean the lower buildings behind the higher buildings, they receive less noise because of the diffraction phenomena. So here, game engine helped to perform this in real time. It's a heavily heavy computation. So you can very fast see that how much, due to the diffraction, how much of sound noise damping you have on the lower buildings behind the higher buildings. So this is all done real time with the game engine functionality. We have shadow analysis, so we have implemented actually the solar azimuth and altitude algorithm there, and we know the geometry of each wind turbine that is added to the scene. So in this way, we could actually make the constructed shadow models of average year, but also instantaneous shadows. Just on the fly, you can just see it, and then you can. Here it goes. So you can see that in real time how many buildings are affected by the shadow of the wind turbine. And here the visibility, because there are studies that they say that, yeah, you specifically hear the wind turbine, you have problem with it if you see it. So we wanted to see how much in real time you can see that if you place a wind turbine, it has the visual impact on how many buildings. And this is also a line of sight analysis. So in GIS, this is difficult to make it real time. So you can see with the functionality of a game engine, they could also have this function of visibility in real time. And here the simultaneous impact of all of it, sound visualization, and so you can see that also the energy yield is in the back. So because it's also a location based, you can see when you place a wind turbine, you can see that it's what the total impact is. So this is part of the system I wanted to show here. We also have added the multi-criteria analysis there. You can also add a score. This is like an auxiliary information. This is not necessary, but I mean necessary in a way that you can also have subjective discussions, but this also helps more to understand also some logics you can place on it, and then you can see here, for instance, also add the weights, because maybe for a wind turbine developer, the energy yield is more important, but for citizens, visibility, shadow, and noise is more important. So you can assign weight and see that based on the scenario that you configure, which one has a higher score than the other one. And then this can help maybe in the discussion, but this is only an auxiliary information. So it's now I have a quarter time, I think. I wanted to talk about this as geospatial data integration, but I wanted to have a small quiz here. I don't know, is it possible that I have some reaction of you on this quiz via the chat? Is it possible?
Let's try.
Let's try. Okay. Very well. So here I have, I wanted to talk about data integration. So here I have an example from Geodan, the company I'm working. We have worked on a 3D virtual environment, and I wanted to ask you to write for me in the chat 2 questions I have. First, I want to ask, do you think this, what type of geospatial data sources has been used for the development of this environment? So which sources that I've talked about have been used? And my second question is that what do you think is missing in the system? And do you think with what type of information we can enrich the environment? So I show this, it's a 2-minute film. Let's see it. Well, if I can see the chat. Yeah, so maybe I do stop sharing so that I can see the chat contents. Yeah, indoor building data indeed. Yeah, BIM models, photogrammetry, spatial data. Okay, now, yes. Yes, so I see more, yeah, procedural design. Yeah, that is, yeah, exactly. So I would, that is all true. So yeah, open data from Videoka. Yes, this actually, open data was the core of it. That is true. We have used LiDAR data for this a lot. Yeah, the land use data we have used. But what is, for instance, missing is the texture of the building. So this system is, of course, of 4 years ago, so now different, but we use yeah, texture of the buildings, so we can maybe use yeah, street view images for that. We could have sensor data in it, actually, which, yeah, the integration of sensor data would also help. Because it's a design of the building, but what I also miss is the impact analysis on the design. So you can see the visual impact, but what it can have, for instance, yeah, of the different impacts that it can add, this type of information, you can just use it by integrating different sensing technologies. So I go back again to screen share. So if I do this screen share, I think you will see my screen. If is that you see my screen?
Yeah, visible.
Very good. So yeah. Oh, so actually, if I want to show that, yeah, there are really a lot of potencies for integrating data from different sources. What we should consider and take care in our infrastructure is that, yeah, this data come from, they have inconsistencies with spatial resolution, with complexity of the geometry, how they are presented. They are from different formats, the update frequency is different, the quality of the data is different, the accuracy, and the privacy issues. So these are some of the important points that we should always take care of when we talk about integration of data from different sources. So now I would like to talk about how I see the sensing technology module in MSc Geomatics. I would like first to position the MSc Geomatics within the Faculty of Architecture and the Built Environment. I think that, yeah, in very headlines I have depicted what the geomatics, yeah, what it's about. It's a very, from very above. It's about the spatial data acquisition techniques of the sensing technology, management of the data, analysis and information extraction, 3D modeling and visualization. So this helps a lot in understanding the current picture of the environment, future predictions. So we can actually use this for yeah, performance analysis of current situation, for yeah, design impact analysis of alteration scenarios, for understanding the mutual impact of the construction and its environment. And that's why architecture and geomatics are really very, they have a lot of complementary role on each other. And here, looking at the course, I see that sensing technology is the first course of the first semester and the first quarter as well. And I looked at it, so to position it, yeah, in the MSc Geomatics where it is, I saw that this course is a prerequisite for digital terrain modeling and for geoweb technology, which is very fair, because by digital terrain modeling and by geoweb, you actually should first understand about, have knowledge about, yeah, what are the different sensing technologies and what are the quality of different technology and the characteristic of it. What I a little bit missed is that I could not find information whether sensing technology is also prerequisite for the 3D modeling of the built environment, this course. In my eye, this is very important because when you want to know what type of modeling techniques are for specific cases, what is a more suitable, and you want to have understanding of the different techniques, it is important to have understanding also beforehand on the different techniques for acquiring the geospatial data. So I would say that they should have this connection. And if we want to make that, then we should think about how to actually align their learning goals with each other. So here we might have a change. And then I saw that the Python programming for geomatics is also in parallel to this course, and which is very fair, very important, because this can be used for the lab course of the sensing technology. That is very important to use Python. And I wanted to a bit now talking about the learning goals of the of the sensing technology. I talk shortly about this Bloom's taxonomy. So that is for to define the learning goals, and that is meant for deep learning. So you go with the lower levels of remembering, understanding, applying, which you should cover the most, of course. And then you go to a higher level of analyzing, evaluating, and creating. And when I looked at the current learning goals of sensing technology, I saw that this is more on the blue part, on the remembering, understanding, and applying, which is very fair, of course, because it's the first course of the first semester, and it's very important that the understanding and applying is very important. And I was thinking about, can we also add something of the higher levels of this Bloom taxonomy? I thought about some suggestions here for this. For instance, in the case of analysis, we can see, so I have also added some, for instance, we can also have focus on some machine learning techniques, which is also important to have an understanding, how can we get the information from this raw data? So maybe for the part of the analyzing, we can have as a learning goal the examining the performance of the different machine learning algorithms, and that part of the evaluating, we can maybe add debating the benefits and challenges in integration of data, like what I have discussed now, but of course more comprehensive. And in the highest level, creating, we can think about integrating different geospatial data and make a new. How can you make something new with integrating different data? So these learning goals are very important to define, because then we should think about that the assignments, formative and summative assignments, and the learning activities, they should be aligned with these learning goals. So here we can, for instance, for this Bloom taxonomy, we can define each level here, and then we can add our learning goals, and then we align our assessments and our learning activities here. So here I do the last part of the presentation. I go to the bridge that, what can my contribution to the GIS technology team be? So looking at this, I see myself with my experience that I can help in the course design, in the lecture, but also in the lab course, because of that I have experience in working in real projects in company, and I have programming experience for now 10 years, different languages. There's many different, but some languages, so this can help me that I can contribute also efficiently to the lab course. And beside that, I saw in the second year, we have a synthesis project and the graduation project. So here the cooperation with companies is, or research institutes is very important. And I can here help because I have a connection with Geodan, Geonovam, Vrije University, and also other networks, because that I, for instance, through my network of Geodan, I know them. I can help in facilitating, defining the use case and the connection of students to this organization for their projects. And I thought about some potential subjects of project topics, which are, for instance, important for Geodan, and also it's also on my own research interest. I thought about like 5 topics. I thought about because Geodan has developed Amsterdam Smart City dashboard, and for them the analysis, pattern analysis, and predictions and traffic flow is an important one. You can think about the automated incorporation of facade texture in a 3D visualization platform. This is also a lot of added value for such a platform of Geodan. We can think about, okay, we have a very large data, like intense, very massive data of the BIM models and so on, and you want to bring them in game engines. So how can you use the OGC3, for instance, 3D tile technique for serving very massive sensor data, or actually also 3D model data specifically, that's meant more for geometrical tiling. How can you use it to enrich the game engine environment with that? We can also, like the research that I have shown on the integration of game engine, GIS, and simulation models, I would like to do some performance enhancement to see that, how can, what is the impact of this integration of game engine GIS in different type of simulation models, and how we can enhance the performance of the simulation models, which are important for the built environment. And the last one, I would think about extraction of elements of city, like a zebra crossing, for instance, which will be needed for the outdoor navigation of users with impairments. This is also one of the projects that Geodan was busy with. So actually, I had defined some goals in the beginning of this lecture, and I hope that I reached it. So I defined some content to reach it. So we have covered the content, and I hope my best that I could make you enthused about the subject, about my own skills. And I would ask you to please help me to reach these goals by asking me questions. This will help me a lot to reach the goal.
Thank you very much, Azhar, and also for being very well in time.
Thank you.
Broad overview. Yeah, indeed, it is time for the questions. Who wants to ask the first question?
Okay.
Please open your microphone and go ahead. Someone from the students, perhaps, present? Okay. Then let me ask a question about the topic you mentioned at the end, when you were discussing the potential content of the sensing technology course, and you mentioned machine learning.
Yes.
And this is a very important topic, and often mentioned in combination with sensing technologies, because we get raw data and we want to say get out meaningful information for people. How would you include that in such a course of sensing technology? And remember, it's indeed the first course in the first quarter of the master. How could you give such a topic a place in the course?
Yes, now that is a very indeed a good question. We can actually, machine learning is like a domain that you can go very deep in it, or you can have some understanding of it. Of course, if you go to the for instance, think about the neural networks, there are really many different type of techniques within these neural networks. But I would say that maybe some like 3 type of machine learning algorithms, but not very deep, but to have some understanding of what it means. What does it mean, machine learning on remote sensing data? And there are also a lot of libraries of Python which are able to do this. And so if you have some overview on a lecture, and then in the lab course, you can also play with it with this, the functionalities of Python, and then you can play with it. Then you can have an understanding that, oh, okay, that is a concept behind it, and you can perform some task. And this is already, I think, a good initial start to have an understanding.
Yeah, thanks. Yeah, if somebody else wants to.
Can I ask something?
Yeah, Stefan, please go ahead.
Sure.
Thank you very much. Thank you, Azar, for the nice and clear presentation.
You're welcome.
I think you know perhaps that our faculty has a broad bachelor education for 3 years, and our students are not so advanced in mathematics.
Yeah.
So if at this moment there is no geomatics education in the bachelor,
Yes.
but our desire is to have it,
Yes.
imagine that you would be asked to contribute in the bachelor education.
Yes.
What would be the topic which is absolutely necessary, which you have to teach for bachelor students of ABA, architecture and building environment?
Yes. I would say really that the sensing technology itself is important. So if you already have an understanding that, what does this data mean actually? How is it, what is the difference between airborne radar, terrestrial laser scanning? So I would say this is really a core course, important course that it gives already a good overview for the students, also bachelor. You don't need to make this very technical, because this you can have it also more on the headlines, or maybe very deeply technical. So I think this is an important subject. And of course, also some subjects about how this data is used in GIS itself. So an understanding on the GIS itself is also very important. But I would not go to the programming, and so you can also use software, like a quantum GIS to perform some analysis, to have some understanding. But yeah, this I would say that the sensing technology course is important specifically, and some course on data management and GIS will be handy.
So you think that every architecture student should learn something about sensing technology?
Yes, because this is about it's about how we can model, how we can actually present the environment so that they can use their design in it. So this connection between the environment and design, I would say it is very important. So that's why I would say that some understanding some technologies of how we can actually model our environment, that is, I think, important for them to learn. But not very technical and not programming. I would keep it more on the concepts.
Thank you. Thank you.
You're welcome.
Okay, Sybil, thank you very much. Other questions?
Perhaps can I?
Yeah,
Just plug in at this point. I think it's a nice link, Azar, with the question I had in mind. You just now highlighted the close connection between the data and the information that is contained in the data, can be extracted from it, and the design process, where there is a certain decision making which happens during the design. You have shown that in the presentation very clearly with the wind turbine location, for example, but I can imagine that you have that translated also in decision making for building design processes or urban design processes. Can you elaborate a bit on that, and on that can eventually link to your body of knowledge and how you might implement that in different occasions, from teaching to research? I ask that considering that within the faculty at all levels, there is a certain emphasis on design, of course.
Yes, of course. Now, that is, of course, very important for this faculty to understand what type of decision support system we can have during the design process, what is important. So, for instance, what I would say is that, for instance, this one of the use cases would be like this integration of BIM and GIS, but in a thinking about in a more in a decision support way. So, for instance, we want to have a design in a very initial, very initial phase of research part of a little research, where we want to where is the best location, where we want to have a residential building. So for instance, we can say that, okay, oh well, what type of view I would have on each from each window. So this is already this can be one of the criteria of for instance, a good location of a residential building. This is an example. But you can also have and this you can do it because, you know, again, there are different type of stakeholders will be there, and maybe for a developer has a different view than for another stakeholders which is there. So this can help and give a like a picture of how it is and how it can have impact the design. We can also think about other construction or more complex constructions, about building, for instance, about a bridge or so. For instance, we can also think about bringing the information of the underground information and above ground information, and see this, what is the impact of the construction, what is the above ground and underground impact, and this type of real-time configuration impact analysis. This can help for during the design process of construction. I would see that.
Yeah, very clear examples. Thank you.
Yeah, thank you.
Art? Yeah, Art, please go ahead.
Different question. Thank you very much, Azar.
You're welcome.
Me being an architectural historian, it's quite interesting to learn about this new field.
Thank you.
I have two questions. Maybe this was given to you when asked to give this presentation, but I'm going to ask it anyway.
Yeah.
At which level of education were you aiming with this lecture? And my second question would be, if you were teaching, for instance, in the bachelor, where we have very mixed population of students, what would you do, or how would you try to find out indeed what the level of the students is, what kind of knowledge they have, and how you can reach them?
Yeah, it is always a very challenging question. Because in our, because I've also for a UniGIS program, I also teach the remote sensing, and this is really, we have a variety of different type of levels and backgrounds of students. There are students which are very technical. There are students which are coming from a more decision-making domain. So it is always very difficult to, at the end, balance the course, which is beneficial for everybody. What we do mostly during our course is that beforehand, we ask, before the course starts actually, we ask our first assignment. It's a formative assignment, we don't grade it, but we ask the students, what do you expect from the course and how do you see it? And we ask some specific question to have an understanding, okay, how we can fine tune the course that is beneficial for majority of the students. This is how I would do that, but also what is very important is that during the course, of course, it depends on the duration of the course. It can be that during the course, you also, based on the formative assessments that you have or the quizzes in the class, the teacher also understands somehow what the expectations or levels of students they are, and you can also adopt during the course. But it's very important to have this frequent formative assignments so that you have, or even during the class activity, so you do some fine-tuning of the content.
Mm.
So this flexible.
What level of students were you aiming with this lecture?
I was focusing on the first semester of the MSc level of the geomatics, but of course this is very, very broad overview it is. So if I want to also focus, I would think about each of these techniques. We would also have to go a bit more on the depth of it, some mathematics on it. So this was really a very broad overview. So I think that can also be used for the bachelor, of course, to have an understanding, what what these sensing platforms are and what can it mean. So that is not very, that can be also used for bachelor students, I would say.
Thank you.
Yeah.
Thanks, Art.
Thank you.
Other questions? Yeah, a topic that has mentioned before is the bachelor and teaching in the bachelor. And yeah, that was something that we are also considering for the future. And then you can also think of a minor. And perhaps you remember in the past, TU Delft participated in the national geoinformation minor, the GI minor.
Exactly. GI minor.
And I think you also did give lectures in the GI minor.
Exactly.
What would you advise us, or when you would become part of the TU Delft, say, rejoin the national GI minor, or make a special program for our own students, bachelor students with their specific background?
But do you mean more for that's both from architecture they can participate and from
the bachelor is the architecture bachelor, and we could one way to say get some geographic information or geomatics at bachelor level. It would be developing a specific minor for these students, and then only a part of them, of course, will select it. Is that a good strategy, or would you say a better strategy is to rejoin the national geoinformation minor together with the Free University of Amsterdam and University of Utrecht and Wageningen University?
Yeah, for me, if I would have this choice, I would go for the first one, because in this way we can focus better and we can also have a better connection to our master program. So here we have the more ability, more freedom for our topics. So that will be better, more supple connection to the master. But of course, these national programs are also very handy because a lot of these practical parts, a lot of this interaction with other universities, this is of course also very beneficial. So you see students from other backgrounds. So it has also advantage and disadvantage. But personally, maybe I would choose for the first one so that we can go more focused to our master, and maybe I would maybe go for the first.
Okay, thank you for your honest answer. I'm a bit surprised. I thought because you were teacher in the national GI minor, you would say, okay, we should rejoin us.
Rejoin it. Now, it has its own advantage, but the problem of it is that sometimes it's not so
it's okay.
focused.
It's okay. Let's use the time for more questions.
Exactly.
Maybe Onno, do you have a question? You're muted.
Yes. Perhaps a question more in general. What do you like about teaching students? What is your motivation?
To teach this? That is a good question. It's always really the first thing is that I have to be always updated. So this, I really like it, that it's a good motivation that your knowledge should be updated, you're challenged, so you can come to challenging questions. As I like it very much. And it gives me always good energy if I have interaction with students, if I can teach something new to them or collaborate with them, work on a research together. It's all this communication, it just helps me. And they are also very young, mainly young generation. I think you learn a lot from them because you come from different type of mindsets with always updated knowledge. So this helps me also be updated and gives me good energy always.
Okay, a good answer, I think. And do you have a specific strategy towards the more lazy students?
I think I would like one of the things that unfortunately here was online. I could not do that very efficiently, though you can always do. I think about in a group teaching, I really believe in it. So if there's a technique called think, pair, share technique, So first you start a lot of discussions or like quizzes. You start with a small group and then you go to a bigger group and then to the class. So it helps lazy students or also students with less confidence. So first to share ideas and then to be a smaller groups and then to go more broad. So this one of the techniques that that I really saw in my teaching, that it really helped in a very good discussion in a class. And I think frequent assignments, this is important. A lot of formative assignments that you just, you don't need to grade it, but you really post a lot of assignments and giving fast updated feedbacks to them. So this actually bring them to more interactions they have to do. So this is more how I use it.
Okay, thank you very much.
Yeah.
Okay, thanks for now. Looking at the time, I would like to count down the last 3 questions. So who would like to have the 3rd question but last?
Maybe I can
Okay,
ask
yeah,
a
please.
question. Azar, thank you very much for your presentation. How do you see the connection between education and research? So how do you involve the students in your research and the things that you wanted to do?
Yeah, that is a very good question, because I saw that in both, the first thing that it came to my mind is about through the projects, because you have there in the both a synthesis project, if I'm not wrong, and also the graduation projects. Beside the possibility of having connection to the companies, you can also participate in an ongoing research. So I would say this would be a very great opportunity also for me as a researcher to have interaction with students on my own research topic, which I can involve the students to the research. But also what I can, if of course this is applicable for the course, if my research and the course that I'm giving that would align with each other, you can also during the course bring part of the research questions and help in, like some maybe higher level of the pyramids, maybe on the debates and so on. So in this way, I actually also indirectly involve students in my research topic.
Okay.
Okay, thank you very much.
Thanks for today, Azar. The second but last question, Edward.
If I'm allowed. Yeah. Also, thank you for your lecture. I would like to go back to a question also, I think, stated by Michele. It happened to be that we are a part of the Faculty of Architecture and the Built Environment, and also our master is called Geomatics for the Built Environment. And for some reason, we consider the environment as already been built. So all houses are already been built, and we downgrade maybe buildings to an outline, polygon, and maybe we are going to create nice looking 3D shapes of buildings, but they are kind of building blocks. And the faculty is also occupied with a lot of students and also researchers who would like to create new buildings. They design new buildings. How can you apply sensing technologies in that kind of design process in building buildings? So that you really have a kind of a feedback mechanism maybe of what about an idea of a building, how to design it, and then how to build it, and what can now what can be the contribution of sensing technologies or remote sensing for that kind of design process?
Yeah, that is actually, I think there are several ways maybe to do that. First, what I also like myself about the sensing technology is that you also learn about, at the end, you use this data for the 3D modeling of the environment. And this is not maybe new buildings that you're building, but it's about reconstructing the current situation. And this, you also have some freedom in how you can do this reconstruction. What type of modelings, what type of techniques are we used to reconstruct? Yeah, it is not a new building, but yeah, these freedoms in sort of modeling of it, maybe it gives a little bit of feeling of building new. But also, yeah, that's a good question. For instance, we can think about I was thinking about some what do you call it in the Dutch bestemmingsplan, for instance, if you can have this data from GIS and then you can see what are the feasibility, where are more feasibility of building buildings is also maybe important first step for building. But yeah, building new buildings, what we, at least I know it from GIS, is more we use it how you can use procedural modelings for building new cities and impact analysis on it. So this is how we use it more in a scenario analysis, in the impact analysis. But sensing technology, especially, I would say, for instance, maybe updating of the building that are changing, detecting changes. For instance, how you can detect the changes, the shape of the building, for instance. Maybe this can help designers with the new situation a little bit.
Okay.
I'm not sure whether I gave a good answer. But
It is
question.
It is a
difficult question, exactly. What interesting.
Who would like to have the last question? Bastiaan, perhaps?
I can have a question, although the presentation was very convincing and entertaining, I think. Maybe you can give me some advice. We talked about the connection with the bachelor, more geoinformation to implement there. What would you recommend as a strategy to better connect the geomatics program to the rest of our faculty? Do you have any ideas how we could implement such a thing?
You mean,
geomatics maybe to general, maybe sensing technologies.
How we can manage. Yeah, I think that to just bring this idea that, okay, this built environment, we make it, but how can we connect this to, for instance, if you want to build a new neighborhood, what should we consider, for instance, and how can sensing technology help different sensors that are, for instance, there, or how can we, in a way, what type of techniques can help us to depict the current situation, which is proper for the design, for the new design, for designing of new environment. Maybe some overview that of the you have this techniques to get the data, but what can it mean for the built environment? Can you use it, for instance, this data, use it in the energy projects, to use it in sustainability type of projects? So yeah, maybe in this way we have a better connection with the built environment, but also, for instance, information on the building information model, BIM model. Maybe we can also have sort of an overview that, what type of sensing technology can be used. For instance, this terrestrial laser scanning inside for the indoor building, for instance, how can this connect to the architectural world? Maybe some more elaboration on that. This will bring this connection between sensing technology and the faculty.
So as a first step, you advise me to send, let's say, to give all the information and send it to the rest of the faculty instead of the other way around, to listen first what's needed and then do the sending.
Oh no, I would say in this case, I would say that I think it is really handy if we have this interaction between us and the faculty is very important. That we should listen to each other and try to interact more in a in a more iterative way. This is we need this data, and what are the needs of the architecture world? What are our needs? What can we do? How can we have a complementary role? So more in a more how do you say it? More natural communication. That is very important. This communication for design of the course, to have this with the faculty, to have this communication. If I understood it correctly.
Okay, thank you.
Clear.
The final last word to Art.
Just a tiny question, since we're discussing all the time teaching in the bachelor. Bachelor is taught mostly in Dutch. Would that be okay with you?
Yes, I am more comfortable with my English, but for Dutch is also I'm fine. Last week a accidentally last week I had to talk to around 40 or 50 people in Dutch, different stakeholders. So it's yeah, no, that is all fine.
Excellent. Thank you.
Thank you.
Okay, thank everybody. Thank you, Azar, for your presentation and also answering the questions in this interactive session at the end.
Yeah.
Yeah, we'll now conclude this session today. Many thanks to everybody for your input. Yeah, we'll be in touch very soon, probably end of this week, next week, and yeah, it's a very exciting process. So thanks everybody.
Thank you very much.
Good afternoon.
Good afternoon. Bye-bye.
Thank you.
Bye.
Bye.
Bye.